0.05 mole per dm cube hydrogen chloride is neutralized by 25 centimeter cube sodium hydroxide. If the volume of acid used is 32.00 centimeter cube, what is the concentration of the base? Solution. From the above question, we can say the reaction between the acid and the base there is a neutralization reaction, and the product we'll be having is salt and water. So before anything, the first thing to do is to write out the chemical equation showing the reaction between the acid and the base. So we'll be doing that now by saying hydrogen chloride, which is HCl, reacting with the base. The base there is sodium hydroxide, which is NaOH. So give the salt we'll be having here is sodium chloride, water. So we've written the chemical equation. After writing the chemical equation, the next thing to do is to check if the equation is balanced, because without a balanced chemical equation, any calculation done will be wrong. So let's see, we have, starting with the base, we have one atom of sodium present here, then we have one as well in the product side. Sodium is balanced. For oxygen, we have one present in the reactant side, and here in the product side we have one as well. For hydrogen, now we have 1 here plus 1, that's 2, and in the product side we have 2 as well. For chlorine, we have 1, and here also we have 1 in the product side. So we can say the equation is balanced. Then let's proceed. So after writing the balanced chemical equation, the next thing to do is to write out the formula we'll be using to calculate this question. I would like us to note that in any question that has to do with neutralization or titration, as some people do call it, also known as volumetric analysis, the formula most commonly used is CAVA over CBVB, which is equal to NA over NB, and that's what we'll be working with today as well. Here Ca is the concentration of the acid, Va is the volume of acid used, Cb is the concentration of the base, Vb is the volume of the base used, while Na and Nb is the number of moles of the acid and base respectively. Ca, Va, Cb, Vb are usually gotten from the question given, while Na and Nb are usually gotten from the equation, and they are the coefficients of the acid and base present. So let's continue. We've written out the formula we want to use. The next thing to do now is to write out the given values. So let's start with the acid. Concentration of the acid, the Ca. From the question given, we have Ca to be 0.05 mole per dm cube. Va is given to be 32.00 centimeter cube. Na, like I said earlier, I said is the coefficient of the acid present. So here we have 1. I have 1. For the base now, Cb. From the question, Cb is unknown, and that's what we are being asked to calculate. That is, what is the concentration of the base. So we have Cb to be unknown. Vb is given to be 25 centimeter cube. And Nb, from the equation as well, Nb is given as 1. That is the coefficient of the base. Let's proceed. Having done this, the next thing to do is to make the unknown the subject of the formula. So the unknown here is Cb. So we'll be making Cb the subject of the formula. We have Cb equals CAVA multiplied by NB divided by VBNA. Let's substitute the values. Cb is then equal to Ca 0.05 mole per dm cube multiplied by Va, which is 32.00 centimeter cube, multiplied by Nb, which is 1, then divided by Vb, that's 25 centimeter cube, multiplied by Na, which is 1. So if we calculate this, we have 1.6 over 25, and the unit mole per dm cube, which gives us 0.064. Unit as well, mole per dm cube. And that's the final answer. So with what we just did now, we've gotten Cb, that is the concentration of the base, to be 0.064 mole per dm cube. Hence we can say that the concentration of the base used is 0.064 mole per dm cube, and that answers the question.